Hello, and thank you for watching this video on the Central Indiana Winter Outlook for this upcoming winter of 2016-2017, brought to you from the National Weather Service in Indianapolis. My name is Mike Ryan. I am one of the meteorologists here. And over the next 25 to 30 minutes, I'm going to break down what we're expecting winter-wise here across the Hoosier State and specifically Central Indiana. Before we begin, though, I want to take a chance to review last year's winter, which really wasn't much of a winter when you looked at all the information came out of it. It was actually a really warm winter to the tune of about 5 degrees above normal here at Indianapolis, and those numbers were similar across the state, across central Indiana. And that was largely influenced by a very, very warm December. You can see we averaged nearly 11 degrees above normal for the entire month. We were a little wetter than normal. We had almost a little under 9.5 inches of precipitation through the 3 months, and we continued wet into March. And then probably the biggest thing that everybody will remember is we did not have a lot of snow last year. Typically in the December to February period, we averaged 22 inches of snowfall. We only had 10.8, so basically half of that. And for the entire year, we only had around 13 inches of snowfall, and we typically average 25.9 here in Indianapolis. It's a little bit more than that as you go north up towards Lafayette, Kokomo, and Muncie, and a little bit less as you go south towards Vincennes, Bedford, and Seymour. So let's begin with the winter outlook that was released in mid-October from the Climate Prediction Center. And this is something that they do every year. And overall, the outlook looks pretty good, but we're going to be able to, through the rest of the presentation, add the context of historical winters and winters that behave similarly to the way we're anticipating this one will behave. And that'll actually be able to help us break down this outlook even further. But you'll notice Indiana is in this red circle right here. And you'll notice we're sitting in equal chances, and you might wonder what that necessarily means. Well, with equal chance, all the Climate Prediction Center is telling us there is they're saying there's no strong signal that would suggest we're going to have a greater potential to be near normal or above normal or below normal. Essentially, we have equal probabilities of each. And as I mentioned, what's going to help us out here in the context of this conversation over the next half hour is looking back at what's happened in similar winters in the past. And from that, as I'll show you going forward, it looks more and more likely that we're actually probably going to trend more towards slightly cooler than normal here over central Indiana as opposed to near or above normal. Now, on the precipitation side of things, Climate Prediction Center has us in a slightly greater chance to experience above normal precipitation. And one of the big reasons for this is because during a winter with La Niña conditions, as we're going to have this winter, conditions tend to be quite a bit drier across the southern tier of the United States, and sometimes that is due to the fact that we have high pressure that parks itself over the southeast U.S., and we've seen that already here through this fall, and we are expecting that to continue into the winter. And as a result of that, the mean jet stream, the mean storm track, is forced up into the Ohio Valley with greater frequency than it might be in winters with other conditions. And so that would tend towards a more unsettled winter and, again, greater threat for precipitation, hence the suggestion that we have a greater chance for above normal precipitation. So I want to go through some basic definitions and just some analysis of the state of the El Niño Southern Oscillation, or ENSO, that we're in before we get into discussing what we're expecting. And let's start with a little definition, as I mentioned. This is basically looking at sea surface temperatures in a region right near where the equator crosses the Pacific Ocean, and that's this white line right here. And what ENSO phase is determined by the anomalies, or the differences from normal from those sea surface temperatures. When we see these temperatures much above normal, when we see much warmer ocean water in this area, like we did last winter during a strong El Niño, we're in that warm phase or El Nino phase. And then when we see conditions where water temperatures are cooler than normal, like they are this year, we would trend towards La Nina, or the cooler phase. During La Nina events, and this doesn't take into account the intensity of the La Nina, but typically being in the La Nina or cool phase means that the weather tends to be more variable across the Ohio Valley and central Indiana. One thing we see is we see a breaking or a split flow pattern often develop, where we can see this jet stream that goes across the Pacific, and we see a polar jet stream that shoots up into Alaska and then back down across western Canada, where it connects back with the Pacific jet stream and drives into the central U.S. and right across the Ohio Valley. This ridge creates warmer than normal conditions out over the Pacific and sometimes over the far western portion of the country. But when we see this kind of pattern with this trough downstream, it tends to open the floodgates for colder air from the polar and Arctic regions at times to come down into the area. But you can see the warm and drier air on the other side of the jet stream is not that far away. And that's why the position of the jet stream is so important and creates so much variability. When we have times where the jet gets shifted a little bit further to the north, then we might see warmer conditions and we might be dealing with rain or storms or a mixture of wintry precipitations. And when we see the jet pushed a little farther to the south, where the colder air has freer rain to come down into the area, then our main precipitation type is usually in the form of snow. So the big thing to take away is that during La Nina events, like what we are going to be in through this winter, we tend to see highly variable conditions, and we tend to be more active because the jet stream is in our region with greater frequency throughout the winter. Now, with that being said, I also stress that no two ENSO events are the same. Whether we're in a La Nina, we've been in La Nina phases before, doesn't mean the weather's going to be exactly the same. There are a lot of factors that come into play. There are other upper level atmospheric conditions, and how those contribute to the type of weather we see with the La Nina phase plays a big factor. And so it's very hard to make any sort of a blanket statement. The biggest thing is to mention that we are in a La Nina. It's a weaker La Nina. And what we're going to do is show you some context going forward as to the generalizations of what we think we'll see as we go through the winter. Wanted to show the anomalies or differences from normal of the water temperatures in greater detail, and NOAA, the Climate Prediction Center, and the National Weather Service use what is called the Niño 3.4 region, and it's an area in the equatorial Pacific where an average of the water temperatures are taken. And you can see, going back to last winter, we were in the midst of our strongest El Nino on record, as water temperatures were averaging nearly 3 degrees Celsius above normal. So it was much warmer. But as we went through the late winter and then eventually into the spring and early summer, those water temperatures cooled rather substantially to the point where they were back near normal, and then actually slipped below normal as we went through the late summer and into the fall. And currently we are sitting between minus 0.5 and minus 1 Celsius. To be exact, the latest weekly reading from the end of October was minus 0.8 Celsius, and that puts us solidly in the weak La Nina phase, which again is identified as water temperatures averaging between minus 0.5 Celsius and minus 1 Celsius. And as it stands right now, the forecast is for us to remain in a weak La Nina phase before we begin to warm late winter and into the spring. And what this shows here, this diagram, is it shows all the different model analyses of the ENSO conditions going forward through the winter and into the spring. These are 3-month increments going out through next summer. So SON is just September, October, November period, October, November, December period, November, December, January period, so on and so forth. And you can see we're sitting in this area here between minus 0.5 and minus 1 degrees Celsius. And this blue line is our projection, taking a average of all the model data. And you can see that shows us continuing to cool into the winter to right around minus 1 Celsius, and then beginning to warm back into the neutral phase, which is between minus 5 Celsius, or excuse me, minus 0.5 Celsius and 0.5 Celsius and that will continue going through the spring and into the summer next year. Okay, so now that I've given you a little bit of background, we'll talk a little bit about what's happened in the past and add the value of some historical context. Now, this isn't going to be a forecast, but it's going to give you some ideas and some general thoughts as to what's happened with similar conditions in the past. And then at the end, I will give you my take as to what I think we're going to see based on the things that I've shown here. So let's start with the winter season normals in Indianapolis. Our average temperature is a little over 30 degrees through the 3 months, December to February. We average a little over 8 inches of precipitation, and as I mentioned earlier, 22 inches of snowfall, with the heaviest snowfall typically averaging out in January. I'm going to start by showing the cold neutral years, and the reason I'm doing that is just if the model projections are a little off and we tend to warm the sea surface temperatures a little faster than what we're showing in that projection. If that's the case, then we may end up back into a cold neutral pattern before the end of the winter. With that being said, when we are in cold neutral winters, at least in the past, we've tended to do very well in the snowfall department, as shown here. We average a little bit above normal with 23.5 inches, and it's not on here, but typically we tend to see snow continue into March and do better. Our precipitation is slightly above normal, and again, we average about 1 to 2 degrees below normal, so we are slightly cooler than normal. In weak La Niña years, the numbers are a little different, but not much. We still end up being a little cooler than normal. That's how we've averaged out, about a degree below normal. We are a little wetter than normal, and you can see we're right near 9 inches, which is a little over 3/4 of an inch above normal. And that's probably due to that storm track residing in the Ohio Valley with greater frequency in a La Niña winter. And with that occurring, that's going to bring storm systems into the area with greater frequency and the potential for more precipitation. And you would expect when the cold air is firmly entrenched that would lead to the potential for more snowfall, and sure enough, you can see that we tend to average just above normal on snowfall. And similar to the cold neutral numbers I showed you a minute ago, we tend to see snow continue into March, and so those numbers go up even further when you include March in with this as well. So when we look back at what's happened in previous winters, what I try to do is I try to find similar conditions in at least 4 to 5 winters that I can use to develop what we call an analog that can kind of give us a rough idea when we combine that all together as to what may take place, just on a very basic scale with temperature and precipitation. And of these 5 winters I have listed here that we used, none of them fit perfectly, but you can see we utilized the 1950-51 winter, the 1966-67 winter, the 1983-84 winter, the 1995-96 winter, and finally the 2007-2008 winter. And of these 5 winters, the 1983-84 and 95-96 winters are probably the 2 that fit the closest to what we're seeing right now here in November and what we're anticipating going into the winter. The 82-83 winter had been a very strong El Nino winter, and by the late fall and winter of 1983 going into the 83-84 winter, we had shifted dramatically into a weak La Niña, similar to what's happened so far this year. 95 and 96, we had not been in a strong El Nino, but we were transitioning into a weak La Niña, again, very similarly to the way we're doing this year. And some of the teleconnection patterns, which I'll discuss here near the end of the presentation, and the projections on those going forward over the next 2 to 3 months, were very similar to what was experienced that winter. So those are probably the 2 biggest winters, at least in terms of looking at what's happened to take to here, to the winter 2016-2017. Biggest thing that you see on the main analog here when you combine the 5 winters is that much of the country east of the Rockies was colder than normal, with the highest departures from normal where we were on the order of 4 to 5 degrees below normal here in the upper Midwest. Here in Indiana, we averaged anywhere from about 1 to 3 degrees below normal on temperatures through the winter. It's important to break down and look at each of the 5 years separately, just because when you take an analog with a number of years, it can sometimes mask signals that show up in the individual years. So let's look at those as well. And you can see they all were starkly different, but in 4 of the 5 years, we carried negative departures from normal on temperatures here in Indiana, and in 2007, 2008, we were not far away from the coldest air, which was to our northwest. This actually shows pretty nicely where the storm track was. It was parked right over us in 2007, 2008, with the warmer air to our south and east and the colder air to our north and west. Interestingly enough, I talk about 83, 84 being a winter that fits very well. You can see how excessively cold it was, that particular year. Christmas 83 and actually late December 83 had some of the coldest air that we've seen in central Indiana and really across much of the eastern part of the country. I was a 7-year-old kid at Christmas 83, and we were down visiting family in South Florida, and I can remember there being freeze warnings up in the Miami area, which is almost unheard of. And it just gives you an idea of exactly how cold it was. Now, when we look at the precipitation anomalies for the 5 years, we talked about, and I showed you the map earlier, that during La Niña conditions, we tend to see drier than normal conditions across the southern part of the country, and that does show up, particularly across the southern plains. And here in the Ohio Valley, extending up into the northeast, we see slightly wetter than normal conditions, which again kind of fits in line with what the Climate Prediction Center is suggesting this particular winter. When we break it down again, however, it shows up, and the thing I love with these maps, and you don't see it on all of them, but particularly on the 1950-51 map, the 95-96 map, and even the 07-08 map, you can see where the wetter than normal signals are with these cooler colors, and that's like the location of the storm track. And you can see we were actually quite a bit wetter than normal in 07-08. And what's interesting is 83, 84, and 95, 96, we were actually drier than normal. You can see that. And if you remember, the Climate Prediction Center suggested we stood a greater chance of being wetter than normal. And you hear me talk about these two winters, 83, 84, and 95, 96, being the two analog years that look closest to what we're expecting this year. You might say, wait a minute, Mike, this is showing drier than normal. Well, there's a little trick in what's going on here. Both of those winters, the storm track was in the area, but it was shifted a little further to the south. So we went through extended stretches of both winters where we were much colder than normal. And as a result, we saw that precipitation falling primarily as snow. And when you have an Arctic air mass over the area, you don't need a lot of water content to produce a lot of snow. So even though we had drier than normal conditions both winters, we did very well in the snow department. Both winters were in excess of 40 inches of snowfall. Now, I'm not suggesting we're going to be quite that high this year, but it's something to kind of keep in the back of your mind as we go forward here with these next few slides before we finish up with our generalizations for this winter. I like to show this graphic just to kind of show the distribution during the ENSO phases here at Indianapolis, and then I'll show the CPC region that covers most of central Indiana. And you can see that we typically average near normal conditions on temperatures during winters of La Niña, and wetter than normal conditions almost 50% of the time. Now, this isn't taking into account the intensity of the La Niña at all. It's just counting all La Niña events. And the numbers are a little similar, but they're maybe more muted when you look at the region as a whole. In fact, the threat for above and below normal are nearly identical, and then we have near normal conditions, again, about 43% of the time when it comes to temperatures. Average precipitation tends to be most common, although there is a little bit more of a wetter signal versus a drier signal when it comes to a La Nina phase. And that's just giving you a little bit of background and context as to what you saw from the Climate Prediction Center's projection. Okay, I mentioned I was going to talk about teleconnection patterns, and I'm not going to go into a lot of detail on this because we could very easily get too technical talking about this. But what I want to do is at least give you a basic understanding of what it is and how these different teleconnection patterns can play into the type of weather we see on a weekly and monthly basis throughout the winter. Now, these are naturally occurring aspects in our atmosphere. They reflect large-scale changes in the wave and jet stream patterns in the upper levels of the atmosphere. You know, a way to maybe think about it is imagine like little rivers of where we see enhanced winds in that jet stream. That's kind of what we're talking about here. Temperature, precipitation, and storm tracks can be influenced based on the phases that each of these teleconnection patterns are in. And they can also be influenced by whatever cycle of the ENSO we're in, whatever phase of the cycle we're in. And so we take that all into consideration, and really there are 6 different teleconnection patterns that can play some sort of an influence on our weather, not just here in the Ohio Valley, but really across the United States. And those are the NAO, which is the North Atlantic Oscillation, the AO, the Arctic Oscillation, the PNA, which is the Pacific North American Oscillation, the PDO, the Pacific Decadal Oscillation, the EPO, which is the East Pacific Oscillation, and the QBO, which is the quasi-biennial oscillation, or the quasi-biennial oscillation. And each of these impact our weather in various ways. Now, I'm not going to go into a whole lot of detail on these, and you don't need to really remember each of these, but it's just, again, establishing a understanding of these different teleconnection patterns and how exactly they can impact us. Now, the North Atlantic Oscillation and the Arctic Oscillation can play a factor, and typically the biggest factor in the wintertime is when we see both of these indices go negative at the same time. It trends towards a much higher confidence in a colder, snowier pattern, and we saw that happen in March 2013. We saw that happen, I believe, in January 2014 as well. And there's a little bit higher confidence that suggests, more colder and snowier conditions. Now, the challenge with the Arctic Oscillation and the North Atlantic Oscillation and many of the teleconnection patterns is that you can only forecast them out about 2 to 3 weeks in advance. And so with the Arctic Oscillation here, you can see we've actually been negative with the Arctic Oscillation since about the first week of October, and that's forecast to continue as we go through the middle of November. The NAO, on the other hand, has been much closer to normal, but it is forecasted to go negative as we go into the second and third week of November, most likely. And the reason I show both of these now is we've been so mild so far this fall. It's November 5th as I record this presentation. The belief is that we are going to shift to a much more typical late fall pattern as we get into the second half of November, and that's going to mean colder conditions and potentially finally seeing our first snowflakes of the year. The biggest problem we've had so far is the Pacific jet has been very strong, and so it's not enabled any of the colder air to come down into the United States. The Pacific jet's been dominant, but as these phases of the teleconnection patterns, the NAO and the AO adjust and go negative, we should see that Pacific jet weekend, which will make it much easier for some of that colder air that's been bottled up in Western Canada, Alaska, Siberia to start to work its way down into the United States. So some things to consider before I finish things up. What role does the Southeast Ridge play? I briefly mentioned it earlier in the presentation. But there's been a persistent ridge of high pressure that's been parked over the southeast United States really since late summer and into the fall. And it's one reason why it's been very dry across the Carolinas and Georgia, back into Alabama. In fact, they've been dealing with some drought conditions down there, and it's because they've been under the ridge of high pressure. And One of the reasons that we think the ridge will remain to some degree through the winter is because that is a staple of a La Niña pattern. And it's one reason why we see the storm track come into the Ohio Valley with greater frequency. The storm track goes up and over the ridge of high pressure, and that puts it right in our area. One thing I didn't talk about, but that's been very impressive so far this fall, the water temperatures on the Great Lakes have been ridiculously warm through the fall, and here in early November, we still have a lot of water in the 50s on Lake Michigan and the upper 40s, which is probably on the order of 5 to 10 degrees warmer than where it should be for this time of year. And some of the reasons for that is many locations across the Great Lakes had one of their warmest summers on record, and so therefore the water temperatures were able to warm more than they typically would. And because of our warm fall, they've been able to retain that warmth and cool much more slowly. Now, that's not necessarily going to have an impact directly for us here in central Indiana, but for those of you up in northern Indiana and up near the Great Lakes, what it means is when the colder air does arrive, the water temperatures are so warm that we're probably going to see some really impressive lake effect snow events as we go later through November into December and maybe even into January. So we'll see what happens with that. I talked about the weaker ENSO phase, the weak La Niña, that typically supports greater influence from other factors like whatever phase we're in and the different teleconnection patterns. Mentioned the active storm track across the Ohio Valley. And really, the colder air, can it entrench for extended periods, is going to determine what our precipitation type is going to be and if we'll be seeing more snow typically. Because when that colder air can entrench, as storm systems are brought up into the Ohio Valley, it would trend towards a wintry precipitation mix or more than likely snow. And finally, the role of the polar vortex. And I'm going to give here at the end a little explanation of what that is because I think it gets misconstrued very easily. But the polar vortex can have an impact in enhancing the cold outbreaks over the winter. And so I'm going to save that bullet for right at the end when I explain a little bit about what the polar vortex is and the impact that can have at certain points of the winter. So finish up with some of my thoughts, and I think they're pretty similar to what we have at the Climate Prediction Center. But based on the analogs that we showed and taking into account the different teleconnections and the weak La Niña, I do think we stand a greater chance to be slightly colder than normal with temperatures over central Indiana this winter, on the order of 1 to 2 degrees below normal. Now, that doesn't mean we're not going to have warm periods or warm stretches during the winter. We certainly will, but I think overall, when you take an average of the 3 months, we will end up slightly cooler than normal. I do think we're going to be wetter than normal with the storm track in the area. I think the potential is there for above normal snowfall. As I mentioned, the two winters that I highlighted, 1983-84 and 1995-96, saw 40 inches or greater. And while that I think is possible if we get into extended stretches of colder Arctic air, like both of those winters saw, I think considering the uncertainty with the storm track right over us, I'm not going to go quite that aggressive, but I do think 30 to 35 inches of snow is possible, which would put us solidly above normal to the tune of about 5 to 10 inches more than we typically see. And I think we're going to see a lot of variability. Again, the position of the storm track with every given storm will be critical. If it's to the south of us, we're probably going to see mainly snow. If it's right over us, we might see a mixture of snow, ice, and rain. And we're likely going to see the potential for at least a couple of events with thunderstorms and maybe severe weather. That's not uncommon in winters, particularly in La Niña. And in one of the analog years I showed, 2007-2008, some may remember that we had the infamous Super Tuesday tornado outbreak on February 5th of that year, which for the most part missed central Indiana. We were impacted by damaging winds up here, but pretty prolific tornado outbreak once you got south of the Ohio River going into the Tennessee Valley and the Mid-South. So take that all into account. Basically, I think we're going to be seeing a more active winter and certainly a snowier winter than definitely we saw last year. So let me finish up with an explanation of the polar vortex. because so often when the polar vortex was discussed during a really cold winter a few years ago, people misunderstood what exactly it was. And it was treated as a new term. And it's not. The polar vortex has been around for a long time. It's a large-scale upper-level cyclone that spins near both of the Earth's poles. And for the northern hemisphere, the polar vortex that spins at the near the North Pole tends to weaken in the summer, but it strengthens in the winter. And a lot of that is due to temperature differences between latitudes and things of that. But when we see the polar vortex having an impact on weather across the Ohio Valley, it's when a piece of that energy can break off and is sent southward with the jet stream. If you remember, when we have that jet stream coming down across the western part of the United States and then developing a huge trough across the eastern U.S., imagine that piece of colder air right here coming down with it. And what that tends to do is enhance the depth of the cold air and the intensity of the Arctic air across the region. So it's not something new, and it's not something you can see, but it's something that does have an influence on our weather. And that's something to remember as we go forward through the winter. So with that, just going to wrap up with a couple of links for climate information via our website. If you have any interest about El Nino or the Climate Prediction Center, you feel free to do that. Again, my name is Mike Ryan. I want to thank you for viewing this presentation. Enjoy the winter. If you love snow, I think you're going to be in for a good winter. And again, on behalf of all of us here at National Weather Service Indianapolis, thanks for viewing. Take care.